this question asks, consider the following synthesis reaction and predict the major product. So we have a multi-step synthesis going on here. We have some reactions that are review, some reactions that are new. So let's go ahead and work our way through it. Anytime you have a big synthesis like this, I say draw out the whole reaction, like every intermediate as you work your way through, because that'll really help you to think about where you are after each step. So we're starting with an aldehyde. And our first reaction is the Grignard reaction. So we know that the Grignard reaction adds carbon-to-carbon bonds. So if we wanted to kind of visualize this, it's like having a negatively charged carbon, and that's going to come around and attack. Okay, so we have a strong nucleophile coming in to attack. After the addition of water, we're going to essentially make this aldehyde, this alcohol, where we have two hydrogens that were originally part of the molecule, and then the new methyl group that we added here. And of course, the end product is an alcohol because we have reduced that carbon to oxygen double bond. Okay, the next step is kind of a throwback to chapter 12 from our Klein textbook, where we use TS chloride and pyridine to kind of improve the leaving group of our molecule. So tosyl chloride and pyridine are essentially going to take our primary alcohol and convert it into OTS. So we've gone from a bad leaving group to a good leaving group. Okay, and then the second step of this reaction, sodium bromide, this is going to be an SN2 reaction. So the product after this kind of second grouping of reactions is essentially going to be an alkyl halide, ethyl bromide. After we make the ethyl bromide, we have kind of a funny looking reagent here, a phosphorus with 3 phenyl groups. And so if you think back to the Wittig reaction, that's kind of the key reagent that we need in order to make the Wittig reagent. So the phosphorus essentially comes in and attacks our alkyl halide, and that's going to kind of make our Wittig reaction. So butylithium then acts as a base, and that's going to give us kind of the key Wittig reagent that we need to carry out kind of the second part of the Wittig reaction, which is the reaction with the cyclopentanone down here. So cyclopentanone looks like this, and that's going to be the molecule that reacts with our Wittig reagent. Okay, the Wittig reagent is going to have 2 carbon atoms attached to it, and so that's essentially what we're going to be adding to the cyclopentanone. You can kind of visualize it as adding the 2 carbons of the alkyl halide to the overall cyclopento group of the cyclopentanone. So we're going to form an alkene as our final product. The key is which alkene. So we have 5 different options here. As we discussed, the kind of 2 carbons that are getting added or added together are forming a new bond, the carbonyl carbon of the cyclopentanone, and then the alpha carbon of the ethyl bromide. So the product in that instance is going to be this molecule. Okay, and that corresponds to molecule number 1. Molecule number 2 has too big of a ring. Okay, so that can't be right. Molecule 3 has the right ring size, but the wrong kind of alkyl group added on. Molecule 4 has the pi bond in the wrong spot. Same idea with molecule 5. Pi bond is in the wrong spot. So essentially, we combined, again, the ethyl bromide here with the cyclopentanone. Oops, that doesn't look like a cyclopentanone. There we go. And that's how we get to answer choice A and molecule number 1.